Hello seniors, today we're going to continue with electronic assignment 27, which is about area and definite integral. If you remember from the first part of this video, we have learned that the definite integral gives us the area under a curve from two specific points of x, right? Remember, we need to define a lower limit and an upper limit, and we would find the area beneath the curve for that interval. Okay, so that's a very important application we have learned from integrals. Now we're going to see the following. It says, when the function f is a non-negative function in an interval from a to b, then the integral of f of x gives the area under the curve from x equals a to x equals b. That's exactly what we just saw. But here's something important that says if f is a non-negative function. So now we're going to study what will happen if f is a negative function. So it says, consider what happens when f is not non-negative. That means that it is negative. For example, in this case, you see that the function in this interval, in this small triangle we have here, the function has negative y values, right? It's below the x-axis. So if we find the integral from -3 to -1, that is, from this value of x to this value of x, we would find the area beneath the curve, right? But the value, so the integral from -3 to -1 of the function, which is 2x plus 2, so if we find that integral using the calculator, we would find that the value the calculator would give us is -4. You can try this using your calculators and you will see that you will get -4. But remember, we're finding areas below the curve, and an area can never be negative, right? So that's what it says here. The area of the shaded triangle is 4, right? A triangle is base times height divided by 2. If you calculate, you will get an area of 4. But if you work with the integral, you will get a negative value. Why? Because since f of x is smaller than 0 when we're analyzing this interval, right? Then it says, if we find the integral from -1 to 2, from -1 to 2, that's from here to here, we would find a positive area, right? So it says, if we find the integral from -1 to 2 of 2x plus 2, then that integral will give us 9. And this represents the area of the shaded triangle, which is this case over here, right? Since f is a non-negative function for -1 to 2, okay? Then for part 3, it says, what if I find the integral from -3 to 2? -3 to 2 would be from this value over here to this value over here. So we're going to be finding two areas, this one over here and this one over here, at the same time. And pay attention to this part. It says, if I find that integral from -3 to 2, we get as a result 5. If you use the calculator, you would see that you would get as a result 5. Why? Because it is equal to the area of the first area we found, which if we use integrals will give us -4, and the second area we have here would give us a value of 9. So -4 plus 9 is equal to 5, right? But if we add the absolute values of the areas, that means if we use +4 here and +9 here, the total area would be 4 plus 9, which is equal to 13, right? That's the normal thing we should do. But it all depends on what the exercise is asking for. So here it says, this is the negative of the area of the region labeled A1 plus the area of the region labeled A2. So it says, this illustrates one of the properties of definite integrals. If I integrate from an interval a to from a value of x equals a and a value of x equals b, then I can separate that integral by using an intermediate point. We can say that this is the same as saying the integral from a to c of f of x plus the integral of from c to b of f of x. That's a very important property that we normally use when working with integrals. Then we have other properties of integrals. It says some properties of definite integrals. If we have the integral of a function which is being multiplied by a constant number, I can take out the constant number. I can take it out of the integral and find the integral of the function itself. Then, if I have the integral of the addition of two functions, I can separate both and find the integrals separately. This is something we already know from indefinite integrals. Then look at this. If I find the integral from one value a to the same value a, that result will be equal to 0. You may try that in your calculators and you will see that it's always equal to 0. Why? Because we're not moving in x. If we're not moving in x, we're saying that, for example, we're finding the integral for x equals 1 from x equals 1 to x equals 1 again. So we're finding like the area of a line, and the area of a line is 0, right? So that's why this integral is always equal to 0. Then, if I find the integral of a to b of f of x, that is the same as saying the negative integral from b to a. So if I flip the limits, the area would change sign, basically. That's what we're saying. If we look at this case, if we go from -1 to 2, we would get as an area 5, right? 9. But if we go from 2 to -1, we're going this way, and the area would have a negative sign. So you would get as a result -9, okay? So that's what this property is saying. And finally, property number 5 says the one that we just described. The integral from a to b is the same as saying the integral from a to c, where c is an intermediate value, plus the integral from c to b, okay? We separate the integral into two portions. That's this case. I can find either the complete integral, which is from -3 to 2, or I can separate it into two parts and find the integral from -3 to -1 first, and then from -1 to 2. And I will get the same result. Okay, so based on these properties, we're going to solve these examples over here. It says, given that the integral from 0 to 2 of f of x dx is equal to 4, the integral from 2 to 5 of f of x is equal to 12, and the integral from 0 to 2 of g of x is equal to -3, and that the integral of g of x from 0 to 4 is 6, evaluate these definite integrals without using your calculator. So you see that we do not have f of x and we do not have g of x. So we would have to apply these 5 properties we have just learned in order to be able to solve these problems. So, for example, in part A says that we need to find the integral from 0 to 2 of 3f of x minus g of x with respect to x. Okay, so if we apply the properties of integrals, you see that, for example, we can first of all separate this from this, and again we can take out the 3. We can take the 3 out of the integral. So this is the same as saying 3 times the integral from 0 to 2 of f of x minus the integral from 0 to 2 of g of x. And then if we replace the values, we know that, for example, the integral from 0 to 2, according to our example, the integral from 0 to 2 of f of x is 4. So this is 3 times 4, the 3 from the constant value we had outside. So 3 times 4 minus the value of the integral from 0 to 2 of g of x, which according to the exercise is -3. So minus -3. So if we solve this, we're going to get 12 plus 3, and 12 plus 3 is 15. So this would be the result for the first exercise. Okay, we're just applying the properties of integrals. Now let's go to part B. Part B says the integral from 2 to 2 of g of x with respect to x plus the integral from 5 to 2 of f of x dx. Okay, so this one over here, we know it's 0, right? Because we're integrating from 2 to 2, so we're not moving in x. So because of that reason, this is 0. Plus the integral from 5 to 2 of f of x. We have here, from our information, that the integral from 2 to 5 is positive 12. That means if I integrate from 5 to 2, I flip the limits, then the answer would flip its sign, right? So instead of being 12, it would be -12. So this is 0 plus -12. So the result here is -12. Okay. Then we have part C, which says integral from 0 to 5 of f of x dx. Okay, so we look at our information, and we do not have integral from 0 to 5. We have from 0 to 2 and from 2 to 5. So maybe if we apply this property over here, we would be able to find the integral from 0 to 5, right? Because we have the two parts that compose that integral, right? So we can say that this is the same as saying the integral from, let me erase this, the integral from 0 to 2, first of all, of f of x dx, plus the integral from 2 to 5 of f of x dx. And we have both of this information. So we substitute these values, and we're going to get that from 0 to 2, it's positive 4, plus from 2 to 5, it's 12. So plus 12. So we get that the integral from 0 to 5 is equal to 16. Okay? Finally, no, not finally, we have 2 remaining. For part D, we want to find the integral from 2 to 4 of g of x dx. Let's see, we have from 2 to 4, we have from 0 to 2, and from 0 to 4. So we don't have from 2 to 4. How can we find from 2 to 4? Maybe to find it from 2 to 4, we can do the opposite, right? Maybe, let me see. We can subtract. Yes, this would basically be the integral from 0 to 4 of g of x dx minus the integral from 0 to 2. I'm subtracting this part, which is from 0 to 2. So I'm gonna be left with the integral from 2 to 4, right? So minus the integral from 0 to 2 of gx dx. So we have both of this information. From 0 to 4, according to our exercise, it's 6. So this is 6. And from 0 to 2, according to our exercise, it's negative 3. So 6 minus 3. And we get as a result 6 plus 3, which is 9. This is the integral from 4 to 2. Finally, for part E, we have the following situation. It says the integral, let me copy that, the integral from negative 3 to negative 1 of 1/2 of f of x plus 3. Okay, this is interesting. Okay, the first thing I see I could do is take out this 1/2 from the integral. So this would be 1/2 times the integral from negative 3 to negative 1 of f of x plus 3. Okay, one thing here. We do not have f of x plus 3. We only have f of x, right? We only have f of x for our given information. But what do you remember from function transformation? What did this plus 3 inside the parentheses cause to the function? If you remember from transformations, this plus 3 inside the parentheses is a horizontal translation 3 units to the left, right? That means that I can rewrite this expression by moving all of the function 3 units to the left. And if I move this function 3 units to the left, let me write that first. F of x is translated 3 units to the left. So we can rewrite this as let me copy this back again. We can rewrite all of this there as 1/2. We're going to keep the 1/2 there, but since we're moving it 3 units to the left, now this is displaced 3 units to the left. So if I move it to its original place, we need to move it 3 units to the right, in order to have it as f of x. So if I move all of the function to the right, it's the same as moving both of my limits to the right. So if I move this 3 units to the right, the lower limit would be 0. And if I move this 3 units to the right, -1 plus 3 would be 2. So basically, this is the same as saying the integral of f of x without the plus 3, because we redisplaced the function 3 units to the right in order to eliminate this plus 3. So this is with respect to x, and now we have this information. According to the exercise, the integral from 0 to 2 of f of x is 4, right? So this is 1/2 times 4, and this is equal to 2. Okay? So this is how we solve these types of exercises using properties of integrals. Okay? And that's it. So I hope this was clear, seniors. If not, please let me know. We're going to clear doubts in future live sessions. Thank you for your attention and see you.